Okay, so let's talk about these series. So this is adding things up, and we're going to spend a ton more time on these than we did on sequences, okay? So these are harder, and I want you to be thinking more about these. So these, we're going to have test names, or a reason why it converges or diverges. All right, so first off, let's just talk about converge or diverge. If convergent, find the sum. So if it says find the sum, I want you to circle that on the question when you're doing a quiz or a test, because I want to make sure that you're just not finding converge. There's two ways to find out if it's convergent. Two ways to find the sum. One is the geometric, and the other is the telescoping. So if you see the words sum, then think of one of these two things. Okay, so what does the sum look like if it's going to be telescoping? It's going to look like something like this. It's going to be polynomial-ish because remember the first step is to do partial fraction decomposition. So it's going to, and I'll let you go look at the rest of the steps on the examples of telescoping, but it's going to be about polynomial looking. Could have a number up here, right? But it's going to have n's down here. No numbers to nth powers. Geometric sum is going to be like a 5 to the negative 2n or a 3 to the 1 minus n. So something with numbers to the nth powers. Numbers to nth powers. So that's going to be geometric, and I'll let you go through the process of like how to find, writing out the first three terms is the best way to find out what the a and the r are equal to. And if it does converge, then the sum is a over 1 minus r. Remember, it will converge if the absolute value of r is less than 1. So write out the first few terms, and then you can find out what the sum is, right? So it will converge if the absolute value of r is less than 1. So telescoping is going to be one of the most rare things because you're not going to have the instructions find the sum too often. So this is going to be rare, this whole long process. That's kind of good. Geometric, if it'll say find the sum, you have to go do the geometric. But geometric is going to be something that we want to be able to recognize. So I'm going to put that over here in the list of tests that we know. So I'll call it geometric. And so if it's a geometric sum, so I guess it's not a test name, but a list of tests, I should say. So if it's a number, right, if it's like a number to the nth power, so like 5 to the negative 2n, I can see that that's the same thing as saying 1 over 25 to the n. I can see that that converges because the r is 1 over 25, right? So I want you to be able to recognize numbers to the nth power, geometric sum, and be able to identify what the r is equal to. All right, so what other tests do we have in this new section here? So one of our most favorite tests you're going to love using because you get to use it so much is the p-test. So the p-test is so easy. Make sure you have it correct. So if I have something like 3n plus 1 over n cubed, you say, can I use p-test on that? Not as it's written. You need to separate it so that I have 1 over n to the p. So all these tests are really specific, right? Has to be 1 over n to the p. So this here, you could pull the 3 outside if you wanted to. 1 over n cubed. So remember, it's this number here. If this number here is bigger than 1, they both converge by p-test. And so converge plus converge means converge, right? So if there's addition, or it could be, so this is an example, right? Or it could be subtraction, right? 3n squared minus n over n cubed. So then I would split it up around the subtraction. So 3 over n, right, canceling as I go. And then minus 1 over n squared. This one would converge by p-test, but this one diverges. And what does diverge mean in series? Diverge means it adds up to infinity. So infinity, subtract a finite number, that means the whole thing diverges. Okay, so kind of make some room here. Okay, so what do we have? We've got the geometric, we've got the p-test, we've got number 3, I'll call the test for divergence. So the test for divergence is kind of tricky because what you do, so if I have this example here, I don't know, like 1 over the nth root of 3. Nth root is not to the nth power, is it? So I'm thinking that's a little bit different. So if I'm going to say I'm doing t for d, so I'm going to take the limit as n goes to infinity, and I'm going to rewrite this as the exponent that it is. Oh, what happens when I plug in infinity? I get 1 over 3 to the 0. Oh, that's 1. So the test for divergence says if this does not equal 0, I can say therefore it diverges by t for d. So if its terms are not 0, the limit of the nth term is not 0. So you never say, let me write this down here again, you never, ever, ever, ever say converge by test for divergence. This is asking to see if it diverges. You get a result, yes, it diverges, or no, do another test. Okay, so what we have so far, geometric, p-test, test for divergence, and then the last one that you just had was the integral test. So this is the most rare, this is the second rare. So integral test, well, when does that get used? I'm pretty sure I wrote this in my notes, but it's things like this, 1 over n times ln of n. It's not geometric, can't use a p-test on it. If I try to do t for d on here, right, t for d means if I take the limit as n goes to infinity of this, I get 0, which means nothing, means more work. So if I get 0 from the limit, more work from test for divergence. So it's when there's e's and ln's, typically that's when you want to use the integral test. And this one, it would have to start at 2, because ln of 1 would give me 0, right? To change it to x's, it's a lot of work. Got to do the u substitution. You have to write the limits all the time, right? We practiced on that from last time, right? So this would be a u substitution. I'm just going to say etc. So integral test when there's e's or ln's, and you have to go through a lot of work to do this. So this is the second most rare. But these here, the geometric, the p-test, the test for divergence, but you're going to use very often, so hopefully you're feeling comfortable with those. And just like when you had integrals, you had to look at the integral, decide what technique to use. I want you to have these like in a list in your head of like, okay, which that test, that test, that test, that test, and I'm going to be adding a lot this week. So hopefully you're feeling strong before the week begins about what you do know.